This is AS Pure Maths Notes. We're on Unit 5, that is coordinate geometry, and we're looking at parallel and perpendicular lines. So it says here the gradient of a line is a measure of its steepness. If two lines are parallel, they are equally steep, therefore they have the same gradient. Perpendicular lines, so we'll consider our two lines here, AB and CD, which cut at right angles. They're at the point E. EF is perpendicular to the x-axis, so that's this wee line kind of going up here, and clearly then alpha plus theta is 90 degrees. That's a wee right angle triangle, that's a right angle, so those two must add to 90, and alpha plus beta is equal to 90 degrees because we've just been told that these two lines then are perpendicular. So let's do a wee bit of maths here and see if we can work this out. First of all, our gradient of CD, so there's CD there, and it's going to be this over this, so that's going to be EF over GF, and that is the same then as tan theta. So why is that? Because look, there's your right angle triangle, that's the opposite, that's the adjacent, so the opposite is EF then over GF. The gradient of the other line in AB is going to be EF over HF, but it's going to be the negative version of that because the line's going down, and that then is minus 1 over tan beta, since tan beta would equal HF over EF. Let's look at that. HF over EF, so there's beta there, so the opposite is here and the adjacent then is here, hence the HF over BF, and then the negative version of that, so that's why it's 1 over. That then equals minus 1 over tan theta, because we just worked out above that beta must equal theta. Let's write that in. Beta equals theta. The product then tan theta multiplied by minus 1 over tan theta is minus 1. So what have we found out? We found out that a product of the gradient of two perpendicular lines in is minus 1. Hence, if two lines are perpendicular, the product of their gradients is minus 1. Okay. And then a couple of examples. So example 1, given A, B, P and Q, find if AB is parallel or perpendicular to PQ. So we need to find the gradients of these and then we'll work it out from there. So first of all, AB, the gradient y2 minus y1, so that would be 6 take away 4 all over 6 take away 1, so that's going to be then 2 over 5. What about PQ? 3 take away minus 1, 12 take away 2, 3 minus minus 1 is 4, 12 minus 2 is 10, and that's 2/5. So gradients are equal, therefore AB is parallel to PQ. Example 2, the triangle P, Q and R is right angled. Find which side is the hypotenuse. We could do this a couple of different ways. We could use our distance formula to find the distance in between all the kind of three sets of points, and then work out how Pythagoras' theorem works. So obviously the biggest one then would be the hypotenuse, or we could find the gradients of the three and work out which one is the negative reciprocal of the other. So we're going to do our gradient method. Let's see how we get on. So first of all, the gradient of PQ equals, so that's PQ, 5 take away 3 minus 1 minus minus 4. 5 take away 3 is 2, and then that's 3. What about QR? Minus 3 minus 5. 0 minus minus 1. That's minus 8 over 1. Which gives us minus 8, nothing to do with that. Okay, let's hope PR helps us out. So we indent PR. So it's going to be minus 3 minus 3. And then 0 minus minus 4. So that gives me minus 6 over 4, which is the same then as minus 3 over 2. So this one here is the negative reciprocal of this one here. So PQ and PR are perpendicular, as in are at right angles to each other. So it must be the point P then. That is the right angle, so the one opposite that then is going to be QR. Let's just take that down in a wee statement so we have an answer. PQ and PR are perpendicular. Therefore, QR is the hypotenuse.